Okay, so um, now we have figured out, um, that we can make various different types of tables. Now, what kind of values should we have um, in here? Well, there's a few different types we could have. We might have like a 3 here and a 5 here. Sorry, it's a little messy there. Um, Maybe this is a 3 and a 5, 3 columns, 5 rows. Maybe it's 4 columns, 5 rows, 5 columns, and 3 rows or 4 rows. A few different ways that we might be able to do that. So I'm not too worried about that. But one thing I would want is for us to talk about the answer here. Whenever we're putting information into a data table, we want to make sure that we've also expressed our units. Okay, so you should have units written in there so that we can always make sure that we understand what our numbers mean. Okay. All right, so now I want you to take a moment and I want you to try to do this experiment. You should be able to do this at home. If you don't have a sensitive balance, then you could kind of create your own if you want. You could just, look up online, try and figure out how to create a micro scale, or, just figure out how can I make a fulcrum with something that's going to be balanced at the top there. You could put, a bunch of paper clips on this side that would be equal to whatever the weight of your gum is over here, and then you could just try to put your gum as you continue to chew it differently and keep putting it on here and to see if it's going to take more paper clips, less paper clips, or the same number of paper clips as you do that. So I want you to go ahead and try and do this experiment. We'll pause this video, and then once you've done it, I want you to also go ahead and answer these questions here. Okay, what observations can you make after you do the experiment, and what questions does that make you ask? And we'll talk about it as soon as you come back. Okay, so now that you have looked at this, let's see what you might have put for some of your answers here. It says, what observations can you make at this point? Well, hopefully you were making the observation that the gum is losing mass, right? So probably had that somewhere in there. The gum should have been losing mass after you do that experiment. You may have never realized that before while you were chewing gum, but this is what happens when you start to chew gum. The gum losing mass, okay, is losing mass. What questions does this make you ask? Well, probably you're asking the same questions that I asked. Why? Why? What's going on here? Why is the gum losing mass? And of course, you might be asking, where is that mass going, right? So why is the gum losing mass? And where is that mass going? Okay, where does the mass go? Those would be maybe some common questions that you might be able to ask. Where does the mass go? Yeah, all right. So now let's think about what we've done here. We've followed 2 steps of the scientific method, but that's really not that significant, right? I mean, we've followed the idea of observing and asking questions, but really nothing is different there than what the ancient Greeks were doing, right? They were doing that much too. So what's different about what we do today and what we've been doing since the 1800s? Well, has to do with where we go from there. We've asked the questions, but now we got to be ready to test, right? So in order to test, we try to predict, okay? And so this is where we're going to try to foresee the future, okay? So can we foresee the future? No, that's bad. We can't foresee the future. No, of course we can foresee the future. If we have a given set of rules about the universe, then we should be able to make predictions, right? We have a name for that. We're going to be asking you what that name is here in a little bit. So the good thing here, and this is really kind of cool, is that when we start asking if we understand the universe, okay, do we really understand the universe that we live in? That's a huge step. Why? Because it means we're okay with getting the wrong answer. It's okay as a scientist to be wrong. We don't assume that we understand everything, all right? As a scientist, we're able to say, no, we don't understand everything. We're trying to understand things. So our pride as scientists, hopefully, is taking a back seat to understanding. Understanding is more important than being right. Okay, we want to understand and discover the truth. We don't want to say, oh, I'm right about this. Now, that might be a little different than what a politician has to deal with, but at least as scientists, we can say, I'm sorry, I was wrong. I made the wrong guess, but now here's the truth. Okay, and scientists do that all the time, and it's called changing your theory, and it's a great thing because we are wrong a lot, but we're discovering the truth. And that's probably one of the reasons we've been able to accomplish so much over the years. So let's go on now to the next page, and we will see what to answer there. All right, so what future do we foresee? Okay, again, I'm asking you to kind of foresee the future. Again, this is not a weird thing, not a bad thing. Remember that God's prophets were able to foresee the future, but remember that in the case of biblical inspiration, that God was the one that was able to give them those prophecies. He was able to help them see that. But He's also given us great minds so that we can predict outcomes, right? So we can predict the outcomes if we are given our previous experience or some given rules. So what do we call that prediction? All right, going to pause here for just a second, fill it in. Okay, yes, it is a hypothesis, right? So a prediction, sometimes you may have learned it as an educated guess, right? The hypothesis, and I'm not fitting it in the blank there, but the hypothesis is that prediction. So what I want you to do now is to pause again, and I want you to actually try to make a hypothesis about the bubblegum experiment. If we were to try and continue this, all right, so we did it for 30 seconds so far, right? We did 0 seconds, we did 15 seconds, and then we did 30 seconds. What's going to happen? If we keep this experiment up, what's going to happen as we go to 45 and 60, et cetera, et cetera, et cetera? As we keep going more and more time, what's going to happen? I want you to try and predict what's going to happen, and I want you to write that answer down here, and we'll pause and let you come back to that here, and we'll check your answer. Okay, so what was your prediction? Well, hopefully you made some sort of prediction that would have gone along the lines of continuing to lose mass, right? So your gum should have continued, okay, continued to lose mass. Now, that's just the first part. If you were really lose mass. If you were really on top of things, you might have also predicted that it was going to eventually plateau, right? So you've chewed gum over and over and over and over again, and you know that gum doesn't just completely disintegrate in your mouth most of the time, right? Unless you've chewed it a crazy amount and you had some cheap gum. No, but really, it doesn't just disintegrate in your mouth most of the time. So we are also trying to say that at one point it kind of flattens out, right? It's going to lose mass until it reaches a particular point, and then it's going to stop losing mass. So continues to lose mass until, and we can just say something like until it plateaued or stopped losing mass, something along those lines, okay? Oh yeah, how do we spell plateaued? No idea. There we go. Maybe it's right. All right, so that should have been your prediction. All right, so let's go ahead and let's make some more observations here. All right, you can see that I've got that hypothesis there. It's probably a good one, and hopefully you've talked about it plateauing or coming to a leveling off point, right? And so now where do we go from there? What's the next part of the scientific method? Now remember, the scientific method is not just a series of steps. So we keep talking about it in terms of steps, but really, you know, it is a way to think about the universe or a way to solve problems. So we are mentioning steps, but the steps don't necessarily come sequentially. And sometimes certain steps aren't there. And so just remember that it's just kind of a way to think about the universe to solve problems. All right, so what are two things that we need to focus on as we go to the testing stage, right? Because this is the next big step of the scientific method, is to test. We want to see, were we actually right? And this is where the Greeks weren't really doing anything, right? They didn't, the ancient Greeks weren't figuring out and testing to see if they were right. Now, some of them might. We have, individuals that were doing a lot of science experiments, and some of them might have been doing some experiments, but in general, the Greek philosophers weren't. So, what do we need to focus on now? Well, we need to focus on two big things. We need to make sure we have control and make sure we have repetition. Control and repetition are two very important aspects of doing any sort of test, okay? We need to make sure it's as controlled as possible. Try to eliminate all the variables, okay? If we were to do this test, if somebody else were to do this test after you, they should be able to do that test exactly the same as you. Okay, but unfortunately, we're always going to have some variability, and that's chance. Because we have variability in the form of chance, then we can never completely control chance. What we have to do is we have to make sure that we repeat our experiments over and over and over again. Okay, so repeat experiments as many times as possible in order to get reliable answers. Okay, so that is one of the things that we need to do in science, and keep that in mind. This is one of the things that Mythbusters doesn't really do. Mythbusters is a great show, great for introducing people to science, and it's really cool. But when it comes down to actual repetition, they don't really repeat their experiments very often. And they admit it. They admit that they're not practicing great science, but man, they are sure interesting and entertaining to watch. All right, so. And now you're going to take a little time. You're going to write down here some of the things that you could do to control the surroundings. Okay, what kind of things would you do to control your surroundings if you were to continue to do, this experiment we were talking about up here? What kind of things would you do to control your surroundings? So we'll pause for a little bit and let you figure that out. Okay, so we're back, and let's see if you kind of had some of the things that I was thinking of. Well, you could make sure that you kept the same temperature, right? What kind of temperature did you have? Whoa, we are super zoomed in here, not what we're trying to do. Let's try that again. Just a little zoom. That's enough. No, okay. All right, so we were trying to perhaps control our temperature, make sure that's the same. You might want to try to make sure you had the same type of gum, right? Maybe you put that down. Maybe you wanted to make sure that you, made the weigh boat the same every single time you did the experiment, that you weighed the gum at the right intervals, that you took the time, that you watched the time very carefully to make sure that you were taking the gum out of the mouth at exactly the same time. Remember, one of the things I had mentioned in mine was to try to make sure that you had, sucked off the spit. Okay, that was in the procedures that I had put in there before. So maybe that was one of the things you were trying to control. Lots of things you could control. What about how many times you chew, right? Oh, sorry about that. How many chews are you going to make for each of those? Okay, how many chews? What about how fast you chew? I guess that might be kind of tied to that. But there's lots of different things you could have here that could be things that you would try to control as far as your surroundings are concerned. Now, we could also repeat the experiment over and over again. In a typical class period, I don't have my students do that because it takes too much time. However, we have repeatability factored in a classroom, and the repeatability in a classroom setting is we've got a lot of people, right? So there's a lot of people in a classroom setting that we can have doing the experiment at the same time. So basically it's, many students is kind of the idea here. If we were to put that in a really brief form, we have lots of students, and that's kind of a repeatability factor there. Now, if you're doing this at home, I would like you to try and do this a few times to see what kind of results you're getting, because you might find the results are a little bit different each time. All right, so even though we have controlled our environment, there's something that we still need to do to test the outcome of our experiment. We need to set up something called a blank group. Now, many of you are familiar with this term, and you are probably thinking already, it is a control group. Yes, it is. It is a control group. Every good experiment has a good control group, and it is what allows us to see if our experimental variable is really causing the change we think it is. Okay, so what would our experimental variable be in this case? Okay, what would our experimental variable be in this case? Well, it's the one thing that we want to change. Okay, that's what the experimental variable is. It's the one thing that we change that might be causing a result, some sort of an effect. And so in this case, what we're doing is we're looking at, the chewing. If I keep chewing, am I going to get some sort of an effect? Yeah. If I keep chewing, I'm going to get an effect that's going to be, differing as I chew even more. Okay, and so in this case, my experimental variable, the one thing I'm doing is I'm chewing more to see if there is an effect or a change. So what does that mean a control group would be? Well, a control group then, in this case, would be to leave the remainder of the gum unchewed and see if it continues to lose weight, okay? All right, sorry, but that's a little silly. I think we all know from our previous experience that if we're not chewing gum, it's not losing weight. This is not a control group that we really need to do, so let's not do a control group for this particular experiment. Later on in this lab, we'll do another control group that will add on to that. All right, so let's continue on with our experiment and see how good we are at predicting the future, okay? Remember, very important here, we don't care if we're right. Maybe you're guessing it's going to lose more mass, maybe you're guessing it's going to gain mass at some point, doesn't matter, maybe you think it's going to stay the same. We don't care. As scientists, we're just about discovering the truth, all right? We're not always going to be very accurately predicting it. Predicting is a component of the learning process, but we're not too worried if we mess it up. Sometimes we don't predict right, and that's okay. All right, so I want you to think about what your hypothesis would, what you would do, okay, if you were to test your hypothesis. So I need you to think about the hypothesis that that we're writing, okay, which is, what we had before on the previous page here, okay? Here's our hypothesis. What would you do to test that hypothesis? I want you to write some steps here, okay? So this is your chance to write a little procedure. So you should have some steps written here, and we'll pause and let you kind of write some steps here. We should have, 1, 2. It's good to write a procedure with steps, kind of like a recipe that people could follow, because we want somebody to be able to do exactly what we're trying to do, and they should be able to repeat it exactly like we did it. So you should have a few steps here that would help you to test to see if your hypothesis, if the gum is going to lose mass until it plateaus, is true. So we'll stop for now, and we'll come back later on and see what you find out.